Hello, my name is Amanda Duong,
And I am Hunter Rojas.
and we are interns from UC Irvine Center of Environmental Biology. We are working with Crystal Cove Conservancy with the Environmental Challenge Project.
Here, we have Sage Modeler. Sage Modeler is an online tool in which allows for importing and visualizing data. We can build, design, and revise models. For this environmental challenge project, we want to know which seed mix is the best, or in other words, most efficient for the state park to use in restoring the land. To do so, we will draw conclusions from 3 different kinds of data.
The first data looks at germination. This is a record of the number of native and non-native plants and species that have grown with each seed mix treatment. The second data is soil moisture, which composes of VWC values. VWC stands for vegetation water content and is measured in percentage. Essentially, VWC is a measure of the percentage of soil that is composed with water. This data can tell us how efficiently the plants use water. Lastly, the third data is cost per pound for each seed mix. By comparing and analyzing all 3 graphs that you generate on Sage Modeler, you can come to a final conclusion to determine which seed mix treatment is the best, considering both effectiveness and costs.
As to making graphs, we are going to give you a quick tutorial by using the germination data as an example. Click on the graph icon that's located on the top panel. In order to fill out the graph, we want the treatment as our x-axis. We're going to grab the treatment from the germination dataset and drag it to the bottom of the graph. Feel free to minimize or resize the data or the text box because your workspace can get very cluttered quickly. Then, we're going to drag our dependent variable to the y-axis of the graph so we can monitor how the independent variable affects the dependent variable. In this case, our y variable is the germination count. Be careful to drag your variables from the same dataset. In other words, be aware when creating your graphs so that you don't accidentally mix up the variables from each dataset.
Your data points should all appear on the graph. The data points should coincide with the data table that was used, and each of these dots means something. For example, for germination, if we are looking at native plants, each data point means the number of native plants that germinated in that specific treatment subplot. If we're looking at non-native plants, each dot represents the number of non-native plants that germinated in that plot, and etc. For us to see which treatment is the highest or lowest in general, we can take the average of the data. For example, we want to see with which treatment the native or non-native plants germinated the most or the least with. We can see this by clicking on the ruler icon next to the graph and selecting mean. By doing this, we will see an average bar on the graph showing the mean for each treatment. To see if our data is credible, or rather if it was based more on random chance, we should add standard deviation on our graph. By clicking on the same ruler icon next to our graph, we can select standard deviation. If there is excessive overlap in our standard deviation bars, that suggests the differences are not as likely to be significant, since the variation is quite large. After you are done, you can click the drop-down button on the top left of the page. Rename and save your document. You can also retrieve a link to shared view.
Try out what you have learned so far. You're going to create a total of 3 graphs to determine what the best treatment is to use for our land managers. After using Sage Modeler, you should come to conclusions on the effectiveness and the costs of different kinds of seed mixes and know how different treatments affect restoration outcomes. Thank you for watching our tutorial video on Sage Modeler